And welcome. This is the 12th video and actually the 6th chapter up to this point. But this is going to be the introduction to human population. This unit is long because it is a really heavily focused on one for the AP exam. So we'll spend a bunch of time in it. Kind of some history, how it's gone. Initially, we were hunter-gatherers, right? So always on the move, locating food or following the herds of animals, following the seasons that fruits and vegetables are going to be blooming naturally. And so we couldn't have a huge population because you had to constantly be able to pick up and move on to the next one. As time went on, we developed agriculture, and agriculture created this need for a lot of people, right? If you're going to have crops, if you're going to have animals that you're looking after and taking care of, that's a full-time job, and so you need to have more people in order to accomplish that. And it also kept people closer together in the same area, gave more opportunities for close contact and breeding, and essentially increased our population. Eventually, that agriculture gives rise to these cities, and again, we're starting to increase even more. Industrialization, we'll get into this later, but it has really dropped the death rates due to technology, producing more food and giving better care for children, helping them survive better, and allowing people to live longer, reproduce longer. So it's really dropped the death rates for industrialization. This is what the graph of human population looks like. You can't see it, but the date right about here is the year 2100. And you can see that for a long period of time, the human population very, very slowly increasing. And then as those cities start to form, we start to see this rise up. We actually dip back down due to the Black Plague. And then as technology, right, it's called the Green Revolution in here somewhere, the 1960s or so, when we started developing synthetic fertilizers and pesticides, really increased how much food we could produce, and so you saw these really high growth rates. And so the graph here ends there, and then who knows where we taper off. And that's going to be one of the big questions in chapter 6 is how long can we sustain this really drastic exponential growth before we hit the carrying capacity wall. And so somewhere here is where the actual number of people the earth can support. Today we're actually pretty close to this 7 billion. This graph is a little bit old. But how far can we go? We're not really sure. This is some growth rate trends in two different types of countries. You'll hear a lot of talk between developed and less developed or developing countries. A developed country is something like the United States, most of Europe. Japan would be a developed country. Pretty well established post-industrial revolution country. A less developed, this one we're talking about Latin America, sub-Saharan Africa, parts of Asia like India and China are less developed countries. Countries that aren't necessarily through the Industrial Revolution yet, haven't really gone through that entire process. And so you can see that the growth is primarily in these less developed countries, right? See how far these light blue bars are outdistancing the dark blue? In fact, over the last 50 years or so, there hasn't been that much growth in the developed countries. Almost all this growth is happening in the developing, and it's gone more than one doubling for those less developed. A lot of this plays into kind of the choices, right? We had the power of doubling lab already at this point, and so population A in that did not have the choice, right? They reproduced kind of unconcerned for the consequences, and that's a lot of times what we see in these less developed countries. Where developed do have the choice. There exists birth control, there exists the education, all sorts of things that we're going to get into that cause this disparity between the two. So current world population as of October 20th, 2014, where we were looking at 7 billion people when I first made these slides. And then this number here, if you go to the website and you can Google population clock, and you'll see this number of people in the world, and it is rapidly rising because people are being born every day. Roughly, it's 4 people per second. And if you did that over the course of 24 hours, right, that's a huge number of people every day, almost 250,000 people every day. So it's still going up really, really fast. This number is staggeringly big, right? 7 billion. We don't often deal with numbers that big in real life, and so it's kind of hard to even imagine a billion of anything. So I've got a couple things for how much is a billion. right? If we have 1,000 seconds, that's 16 minutes. 1,000,000 seconds is 11 days. So we've gone up there by an order of 1,000. And then if we have 1,000,000,000 seconds, that's 31 years. So we'd have to put two of you together, right? Two students together to get to 1,000,000,000 seconds. You're both probably about 500,000,000 seconds now, maybe a little bit more. Same thing, pennies, right? If we put 1,000,000,000 pennies together, that's the equivalent of 2 space shuttles or 2,000 tons, right? An awful lot of pennies. So billion is a huge number. Here's our uneven distribution I was talking about in that previous graph. In the developed countries, we're growing at this very low, manageable rate of 0.1% per year. The developing, though, 1.5% is a huge percentage, right? Your bank's not going to give you 1.5% annual interest on a savings account. So this is a really nice number to be talking about if we're talking about bank accounts. Unfortunately, it's for people, and so every year we're getting 1.5% more people than we had the year before. Here's our projections. In the year 2050, we're projected to hit 10 billion. And if you average out the developing and the developed, this is about our annual growth percentage, right? And so we could do 1.22 and set that equal to 70 over the number of years to develop. And we can figure out, right, how many years does it take for this population to double at that percentage? It would be interesting to find out. Some factors, why is it rising? What's happening to the population that's pushing it up? One of them is our ability to expand to new habitats and climate zones. So as we developed air conditioning and heating, we can get to regions of the world that were previously unable to support humans before those features. We also have added in like clothing is something that is a more modern development, right? Ancient ancestors probably weren't wearing too many clothes. Now we have a lot of different options, and we can, again, expand even further. This is a really big one, the modern agriculture, and it's referred to as the green revolution. Synthetic pesticides and synthetic fertilizers have really pushed that to the next level. Using like petroleum distillates to create these things have really boosted our food reserves. And there's no such thing as a food shortage anymore. The real problem is a food distribution problem where we're not getting it to the people that really need it. And that is kind of a different topic there, but there's no such thing as food shortage due to modern agriculture and that green revolution. And then this is also a really big one too. Improved healthcare. People are living much longer, and due to improvements in healthcare, can be reproductively successful much later in life. If you think about like the Middle Ages, where you were lucky to reach 40 years old, there are people now that are having healthy children close to 40 years old or even beyond 40 years old. We also have really improved sanitation, right? Something like germ theory. And understanding bacteria has gone a long way to improving this, especially dealing with medical procedures and also sources of water, right? We're being able to purify, filter water that previously might have carried things like cholera or dysentery, things that would act as population controls, no longer have pressure on the human population because our technology is able to help us exceed those previously old carrying capacities. Some things to be aware of for population dynamics. There are 3 ways that it can change. One is through new births, one is through deaths, and the other is through migration, right? We've got emigration, which is going out and leaving a population. Immigration, I know my head's kind of covering up some of this, but it's immigration. Immigration would be coming in. Births, of course, these are new babies being born, so that's adding to the population. Deaths would be the opposite, going out. And so the natural decrease is just a kind of a definition, vocab word to know. Natural decrease is what happens when you have more deaths than births. Something's going on over in Japan because our population there is really skewed to the older generations. We get more deaths than births. Couple things to be aware of, right? CBR, CDR, extremely important for this course. We're going to see a lot of them. The CBR stands for crude birth rate, and it's the number of births for 1,000 people in a population, right? And so it's controlled for this 1,000 people. You can see kind of how it's changed. We'll use it to look at different countries too. You can tell a lot from this crude birth rate. A crude birth rate of 20.6 is a pretty high crude birth rate. We would expect this population to be growing pretty rapidly. You get a more clear picture when you look at it compared to the crude death rate. So again, how many deaths are there in 1,000 average individuals of population? And for this one, we have 8.8 as our crude death rate. Pretty low crude death rate. So this population here would be growing, right? Our births are exceeding our deaths, and so every 1,000 people, we're getting in an extra, an extra 11 people or so. So in this case, we'd have positive growth rate, and you can see it right here. So we can calculate the growth rate. This is births and immigration minus deaths plus emigration for a country. But crude birth rate, crude death rate, really important. We'll kind of talk about some ranges for them and what it means if the crude birth rate falls in that range for the country. So this is kind of a births per 1,000. So this is our crude birth rate graph. And you can see the regions that have really high crude birth rates, right? Sub-Saharan Africa. We've got some Central America, and we've got this portion of Asia and the Middle East that have really high CBRs. These are going to be our developing countries, and we see a really high CBR in developing countries. On the other hand, if you look at the deaths, right, crude death rate, we see, again, pretty high crude death rate in Sub-Saharan Africa, pretty high in Latin America here, and again, Asia and the Middle East have a pretty high crude death rate. We also see some pretty high crude death rates in the United States, and even a pretty high one here in Eastern Europe. Part of these is due to such a high average age, right? People are living longer, and those people, as they live longer, you kind of end up with a log jam of people in the upper levels, in the older age brackets, and so that can cause a higher crude death rate. This is our TFR, total fertility rate, and the TFR is an important thing we're going to go over in a minute. But if you'll notice, the higher the TFR, talking Sub-Saharan Africa, Central America, the Middle East, and Southeast Asia has high TFR. These are all our developing countries with a high TFR. I'm going to skip that one for a second, just so I can cover TFR before the video ends here. TFR stands for total fertility rate, and it's the average number of children born to a woman, right? So the man is not really important in this equation except for causing that birth to happen. But the TFR is how many kids does the average woman have in that country. And so they would calculate this by finding the number of births in a year and the number of women that were alive in the year, and then simply divide it out. And so you can see the average TFR in a developed country is about 1.5, meaning each girl or each woman in this population has about 1.5 kids. For developing, it's a much higher number. And so 3.8 kids per woman is a very high amount of growth. And again, we're seeing that in developing countries. We'll get into why that's higher in later videos. The RFR is another thing to be aware of, replacement fertility. This is kind of like the ideal number here. What we would like to see the TFR be is the RFR. And the RFR is how many kids do they need to have to replace, right? So under this, we have zero growth, right? If we're under replacement fertility, there's no growth because we're having just enough kids to replace the parents. And so the couple would have the number of children to replace themselves. For a developed country, we're looking at 2.1. It's not exactly 2 because there is a very low infant mortality rate in developed countries. Some babies do not make it to reproduction, and so you need to have slightly more. That doesn't mean one woman needs to have 2.1 kids and lose that other 0.9. It means you'd have some that have 2 and then a couple that would have 3. Africa replacement fertility is much higher because we have higher infant mortality rates, right? More of the kids born in Africa have a smaller chance of not making it to adulthood, right? So higher infant mortality means you need to have a higher replacement fertility. And I'm going to end it on this slide, so please come tomorrow with notes and be prepared to discuss what we talked about there. Thank you for watching.